Alright, so we're just going to pick up where we left off in the last video, which would be on page 54. And so if it's been a little while since you saw the last video, you might want to review the example, but we calculated a confidence interval for the proportion of medical malpractice lawsuits that were dropped or dismissed. And so we got down to here, and we calculated the confidence interval to be between 0.6632 and 0.7308. And so that means that we're 99% confident that the number of or proportion of medical malpractice lawsuits that are dropped or dismissed is between 0.66, we'll just round a little bit so I can fit it in there, and 0.73. Okay, remember we got an estimate. Our point estimate was 0.697, but we know that's going to be off a little bit, so we add and subtract the margin of error. And that's how we get an interval with a lower bound and an upper bound. Usually when I interpret confidence intervals, I will change it to a percent. I think that just makes a little more sense. And so I say we can be 99% confident, because this was a 99% confidence interval, that between 66% and 73% of medical malpractice lawsuits are dropped or dismissed. Okay, so that's how you interpret your confidence interval. You state the confidence level and then the percentage that it's between. So we're trying to estimate the proportion of medical malpractice lawsuits that are dropped, and our estimate is anywhere between 66% and 73%. We don't know exactly where it lies, but somewhere in between there. And then it says, does it appear that the majority of such suits are dropped or dismissed? So when we say majority, that would mean greater than 50%. And so since our confidence interval is above 50%, the answer would be yes. I'm just going to write CI for confidence interval is above 50%. Okay. Alright, so the idea is that we go out and collect data. We get a point estimate, 0.697, and then we create a margin of error. So that gives us a little wiggle room because we're trying to estimate the true proportion. Okay, so let's go and do another example. I believe that sample size will be covered in class. And so we're going to go down to this example right here. So we're on page 56. Okay, so it says the Genetics and IVF Institute conducted a clinical trial of the XSORT method, and that's designed to increase the probability of conceiving a girl. As this book was written, 325 babies were born to parents using the XSORT method. Alright, so that's our sample size. We want to keep track of that. That's going to be N. And 295 of them were girls. That's going to be X. That's how we calculate our sample proportion. In this case, our sample proportion would be the proportion of girls. Alright, so we want a 99% confidence interval of the percentage of girls born to parents using this method. Alright, so the first thing we need to do is calculate p hat. That's the proportion of girls born. So out of 325, 295 out of 325 were girls, and so that gives us a value of 0.902. Alright, so it does actually look like it's pretty effective, 90% girls. We also want to calculate Q hat, which is 1 minus 0.908, and that's going to equal 0.092. Alright, so now we can calculate our confidence interval. We want a 99%. And so we take, and I'm just going to calculate this as one equation, we take 0.908. Let's go up real quick to the equation that we're going to use. That's on page 55, and I'm just going to calculate it all at once. So I'm going to use this equation right here. If you like to do it in steps, you can first get the margin of error. I wanted 99%, so I'm going to use this 2.58. Okay, so I'm going to start right here. I have 0.908, that's my p hat, plus or minus 2.58. And then I take p hat times q hat, so 0.908 times 0.092. And that's divided by our sample size, so 325. Okay, so this works out to be 0.908 plus or minus our margin of error, so that's this chunk right here. Just doing this in steps. So plus or minus 0.041. Okay, so I take 908 minus 0.041, so that's 0.867. And then 0.908 plus 0.041, and that's 0.949. That's a 4. And this is an 8. Okay, so if you use this method, we're 99% confident that the proportion of girls for parents who use this method is between 0.867 up to 0.949. Okay, so let's go ahead and interpret that confidence interval. Alright, so I say we are 99% confident that for parents that use the XOR method, the percent of girls born will be between 86.7% and 94.9%. Okay? Alright, so the other question is it effective? And the answer would be yes, it is very effective because they're almost all girls. Okay. Alright, so there's another example. We can do this on the calculator as well. And I want to go to Stat. I want to go to Tests. And then I go down to letter A, 1 prop Z interval. The prop stands for proportion, and the interval stands for confidence interval. Okay, so I hit enter, and then I put in my value for X, which is 295, and I put in my value for N, which is 325, and my confidence level is still 99, and I hit enter. Okay, so I get a confidence interval that should be fairly close, 0.867, very close, and 0.949. A little bit off just because of rounding error. Okay, so now you know how to calculate and interpret a confidence interval.